Hello and welcome to our lesson on absolute value inequalities. This is going to be from section 1.6 from our text. Let's get started. In this lesson, I'm not going to jump straight into the examples first. We're going to look at some special cases that you need to be aware of. These absolute value inequalities can be a little bit tricky if you're not paying attention. Okay, so let's start with probably the easiest scenarios you're going to see. The absolute value of x less than a negative number. Okay, this would be one of the easiest scenarios you would see because absolute value, remember, that's always going to be positive or at least zero. Okay, so let's think about this. Are positive numbers or even zero going to be less than a negative number? Can that ever happen? And the answer is no. So in this case, your answer would be no solution. You don't have any work to do because the absolute value can never be less than a negative number. It's always going to be positive or at least zero. All right, so a cousin to that would be the absolute value of x less than or equal to a negative number. And again, since absolute value is always positive, a positive number cannot be less than or equal to a negative number. Even if this was zero, zero cannot be equal to a negative or less than a negative. So again, you would have no solution. Those are tricky situations where if you're paying attention, it's going to be super easy because it's just no solution. Another couple of scenarios would be if you have the absolute value of x greater than or equal to a negative number. Here, remember, this quantity is going to be a positive or at least zero. And if you think about this, are positive numbers greater than or equal to a negative number? Always. Even if it's zero, zero is greater than or equal to a negative number always. And so this would be a case where there's no work to show. The answer is going to be all real numbers, infinite solutions. And we're going to express that in interval notation, minus infinity to infinity. Okay? Similar to that would be if you have the absolute value of x greater than or equal to zero. This, again, this would be all real numbers, infinite solutions, because remember the smallest that this absolute value can be is zero. And zero is equal to zero, so that would be true. And then any other number that you plug in is going to end up being a positive, which again, positive numbers are always greater than zero. So this particular setup would also be all real numbers. No work to do, it's just all real numbers. And so those are some weird scenarios that you may run into that you need to really ask yourself, what's going on here? Is this never going to happen, or is this always going to happen? All right, so let's talk about some even trickier situations that you need to be aware of. If you have the absolute value of x less than or equal to zero. Now, this one is kind of tricky because if you're just thinking, well, absolute value is always positive, you're going to think that this is no solution, right? Because positive numbers can never be less than zero. But remember, an absolute value can be zero. It is possible for an absolute value to be zero. And in that case, would zero be equal to zero? The answer is yes. So anytime you have the absolute value of some stuff less than or equal to zero, it's not no solution. There is only one solution. And in this particular problem, the only answer would be zero. Zero is the only number that I can replace x with and get a true statement there. Okay, what if I had the absolute value of x strictly less than 0? Well, that would be no solution, because even if I plug in a 0, 0 is not less than 0. That's false. Every other number would be positive, which would be greater than 0, not less than 0. So in this case, this would be another no solution. Okay, again, subtle difference, different outcomes. Okay, now then, let's think about another tricky scenario. Absolute value of x greater than 0. And again, you might think, well, if this is always positive, positive numbers are always greater than 0, then that's going to be all real numbers. And that would be false. You know why? Because 0 is part of the all real numbers. But if I replace x with 0, do I get a true statement? Is 0 greater than 0? That is false. And so in this crazy setup, if you think about this on a number line, okay, at 0, you would actually have an open circle because 0 produces a false statement. 0 cannot be included in this solution set because it doesn't make a true statement. But any other number that I plug in will be greater than 0. So that's what the graph would look like on the number line. It would be everything shaded except 0. The way you would express that in interval notation, everything from minus infinity to 0, not including 0, skip over 0, and keep going. That's the way that solution would look in interval notation. This is all real numbers except 0. Okay, what about set notation? You would say, hey, the solution set is the set of all x such that x cannot be 0. That's the way this answer would look in set notation, because this says, hey, x can be anything but 0. And those are the tricky situations that you're going to need to look out for, okay? Now we can jump into actual examples. So we're going to start with number 75. Here we have the absolute value of x minus 1 less than 1. And so the poem that I'm going to give you that you need to live by here, listen, if it's true, split it in 2. Okay, so remember this absolute value means positive or at least 0, okay? Is positive stuff less than 1? Are there positive numbers less than 1? Yes, like a half, a third, a sixth. There's a lot of positive numbers less than 1. So this statement is true because there are positive numbers less than 1. If it's true, split it in 2. We're going to say x minus 1 less than 1. The first time you're going to copy and paste and leave it the same. And then you're going to copy and paste again, change the inequality and the sign. When you copy it a second time, you flip the arrow and the sign, okay? And then we're going to need a word in between. It's either going to be and, or it's going to be or. And what determines the word is the original inequality. Less than is and, greater than is or. And it will make a difference if you get this wrong. You have to get the right word there. Now that I've got it split in 2, I need to solve for x. Moving the minus 1 over makes it a plus 1. X is less than 2. And moving the minus 1 over makes it a plus 1. X is greater than 0. So there's our solution for this absolute value inequality. The next thing we need to do is go to the number line. I've got 2 critical points. Please make sure you put them in the right order, 0 and then 2. And they're both going to have open circles, right? Because neither one of them has the equal to part. And let's talk about the shading. Remember in a previous lesson I said if the letters on the left shade the way the arrow points. So from 2, we're going to shade to the left. And again, if the letters on the left shade the way the arrow points, for 0, we're going to shade to the right. And do you see there's shading in the middle? Now that's where the and comes from. If it's an and inequality, you're going to have shading in between. If it's an or, you're going to have shadings on the outside. But there's the graph done. The last thing we're going to do is we're going to write this solution in interval notation. That's going to be everything from 0 to 2. And if you're wondering why did I use parentheses, it's because I had open circles. Open circles correspond to parentheses. Remember, the open circles were because we had strictly less than and greater than. And there is the solution for number 75. Now for number 77, I get to teach you something new that I haven't said yet. If you're going to solve an absolute value inequality, the absolute value has to be isolated. That means only absolute value stuff on one side. And so notice here, we have a coefficient of 5 that is outside the absolute value. I'm going to have to get rid of it. In order to isolate the absolute value, I'm going to first have to divide both sides by 5. And that'll give me the absolute value of x plus 4 is less than or equal to 2. Do you see what I mean by isolate the absolute value? All by itself. You can have a lot of stuff inside the absolute value and it's still isolated as long as it's just absolute value stuff on one side. Now, next step, remember I said if it's true, split it in 2. Is positive stuff less than or equal to 2? Yeah, there's some positive stuff less than or equal to 2, correct? Like 1, a half, a third, a sixth. Yeah, there's lots of positive stuff that is less than or equal to 2. If it's true, split it in 2. And remember, we're going to copy and paste and keep it the same. And then we're going to copy and paste, change the inequality and the sign. Next, we need to determine what word is going to go in the middle here. And that's going to be determined by the original inequality. Just like number 75, we had a less than. Here, if it's less than or equal to, it's still going to be and. And it'll make a difference if you miss that, okay? So make sure you get that word right. Next step, we need to solve for x. Moving the plus 4 makes it minus. X is less than or equal to negative 2. And moving the 4 over makes it minus. X is greater than or equal to negative 6. Now we have the inequality solved. The next step is to go to the number line. Here I have 2 critical points. Which is the leftmost? Negative 2 or negative 6? Yep, negative 6 and negative 2. And it will make a difference if you get those backwards. So please make sure you get those in the right order. We're going to have solid dots this time because we have the equal to part. And let's look at the shading. Remember, if the letters on the left shade the way the arrow points, so from negative 2, we're going to shade to the left. If the letters on the left shade the way the arrow points, so for negative 6, we're going to shade to the right. Now, remember we said that this word is important and takes the overlap. So we're only going to take the shading in the middle because that's where the shadings overlap. and will always shade in the middle. And the last thing we need to do is we need to write the interval notation. And so the solution set is going to be everything from -6 to -2. The brackets are because we had solid dots. And remember, those brackets, they say up to and including. So -6 and -2 are included in this solution set. And the solid dots came from the equal to part. Okay, and that is it for number 77. Next example, number 81, we have the absolute value of 2y minus 7 greater than 10. So the absolute value is isolated. It's all by itself on one side. And then remember the next step, if it's true, split it in two. Well, there is definitely positive stuff that is greater than 10. So we're going to split it in two. And the first time you split it, you copy and paste. You leave it the same. The second time, copy and paste. Change the inequality and the sign. Now we need to get the correct word in the middle. Greater than is or. Greater than or equal to or greater than, both of those would be an or statement. And now we can solve for y. Moving the -7 makes it positive. That's going to give me 2y greater than 17. If I divide both sides by 2, that is not going to divide nicely. 17 halves is not going to divide nicely. So I'm going to leave it effed up. I'm going to leave it fractioned up. I like it improper. Or bringing the -7 over makes it a +7. That's going to give me 2y less than -3. Then if I divide both sides by 2, that is also not going to divide nicely. So I'm going to leave that effed up, leaving it in fraction form this time. You know what? If you wanted to make those decimals, like the -3 halves would be -1.5, since it's a terminating decimal, that would be okay. If it was a repeating decimal, you would definitely want to leave it a fraction. But terminating decimals, it's okay if you convert them to decimal form. Now, to the number line. I've got 2 critical points. Please make sure you put them in the right order. -3 halves on the left, 17 halves on the right. Those are both going to be open circles because we don't have the equal to part of the inequality. And let's talk about the shading. Remember, if the letters on the left shade the way the arrow points. So from 17 halves, we're going to shade to the right. If the letters on the left shade the way the arrow points, -3 halves is going to shade to the left. And there is the shading done. Now for the interval notation. Remember, an or means union. And a union says to take all of the shading. It's okay if they don't overlap. And has to have overlap, or does not. So this solution in interval notation would be everything from -infinity up to -3 halves with a parenthesis because of the open circle. And then remember, the U is the glue that sticks the two pieces together. So we have to have the union symbol. And then we're going to pick up again at 17 halves with a parenthesis, again because of the open circle, to infinity and beyond. And we're done. And that is it for problem number 81. Number 103, I saved the best for last. Here we have an absolute value inequality where the absolute value is definitely not isolated. And so we're going to have to go through the process of getting the absolute value all by itself. First step, we're going to have to bring this 7 over, and that's going to make that minus 7. We have to get rid of the extra term, and then we're going to have to deal with this negative sign. But the first step is to move the 7 over. That's going to leave me negative absolute value of 3 minus 2x greater than or equal to negative 2. Now I can get rid of the negative. Now, if you think about this, this is really an understood negative 1 coefficient. Really, there's an understood negative 1 being multiplied by this absolute value. So to get rid of that negative 1 factor, I'm going to have to divide both sides by negative 1. So again, understood negative 1, those will divide out and leave me just the absolute value of 3 minus 2x. And then I have to remind you, anytime you divide an inequality by a negative number, the inequality has to flip. And a negative over a negative makes a positive. So now that's less than or equal to 2. Now the absolute value is isolated. Now I can ask myself, is it true? And then split it in 2. Okay, so is there positive stuff that is less than or equal to 2? And the answer is yes. There's a lot of positive numbers that are less than or equal to 2. So since it's true, we're going to split it in 2. And the first time you split it, you keep it the same. 3 minus 2x less than or equal to 2. The second time you split it, the only thing you change is the inequality and the sign of the 2. So when you split it the second time, you change the arrow and the sign. Got it? Now, what word should go in the middle? What word should go in the middle? Well, we're going to have to go to this step here where the absolute value is isolated and then say, well, this was less than or equal to. So this is going to be an and inequality. You go back to the step where the absolute value was isolated, and that's where you determine whether it's an and or an or. And now we're going to have to solve for x. Moving the 3 over is going to give me negative 2x less than or equal to negative 1, because 2 minus 3 is negative 1. And then if I divide by negative 2 to get the x by itself, oh, look out! I divided by a negative. I got to flip the inequality. And a negative over a negative makes a positive. So that'll say x is greater than or equal to positive 1/2. And we have to solve the other one. Moving the 3 over again makes it minus 3. That's going to give me negative 2x greater than or equal to negative 5. And again, dividing both sides by a negative number makes the inequality flip. Negative over a negative makes a positive. So once we get our solution, then to the number line. I've got 2 critical points. Which one is the smallest? Which is the leftmost? Yes, it is 1/2. 1/2 is smaller than 5/2. A proper fraction is always smaller than an improper fraction. These are going to be solid dots. And for the shading, if the letters on the left shade the way the arrow points. From the 1/2, we're going to shade to the right. If the letters on the left shade the way the arrow points, 5/2 shades to the left. Our shadings overlap in the middle. Remember, and is intersection. You want where the shadings overlap, that's going to be in the middle. And if you haven't noticed this yet, let me just point this out, that if you have an OR, absolute value inequality, you're going to have a gap. If you have an AND, absolute value inequality, you're going to have shading in the middle. And that's going to always be the case for the absolute value inequalities. Last step for this last example, I need the interval notation. That's going to be everything from 1/2 to 5/2. And do you know why we have brackets and not parentheses? It's because we have solid dots. Why do we have solid dots? Because of the equal to parts. And that is done. And that is it for this particular lesson. So if you have any questions or comments about anything that I've covered, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.